All right, let's have a look at our practice quiz number 4 here. You guys, question number 1 says a proton collides with a stationary alpha particle. You guys have all heard of a proton before. Science 10 for sure, probably even before that. You might not remember the details of you probably don't remember what the mass of a proton is. You probably never heard of an alpha particle before, I'm guessing. We read this question, a proton collides with a stationary alpha particle after the collision, blah, 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 blah. Doesn't matter, right? Context of this doesn't matter. Two things colliding, we know what to do when two things collide. Doesn't matter what it is. This is a conservation of momentum problem, right? Just like if I said a 1973 Chrysler New Yorker collided with a 1978 Ford Pinto, you don't know what a Ford Pinto is? I do, because we used to have one when I was a kid. You don't know what one is. Like, you've never seen a Ford Pinto before, though. Doesn't matter. You would treat this question like you do any other question involving conservation of momentum. So this is no different. You just need some data for the proton and for this mysterious alpha particle thing. The mass of both of these is found on our data sheet. The mass of a proton, I'm going to call M1. And that mass from our data sheet, correct me if I'm wrong here, guys. I believe from memory it's 1.67 times 10 to the minus 27 kilograms. And the mass of the alpha particle from our data sheet, I believe, is 6.65 times 10 to the minus 27 kilograms. Those right? Those numbers right? After the collision, the proton moves. Oh, sorry, the stationary alpha particle. I'm going to say V2 initial is 0 because it's a stationary alpha particle. I remember this question now. The wording of this kind of bugged me a little bit, actually. After the collision, the proton moves opposite to the direction of its initial motion. So I don't even know what the initial motion of the proton was. We're going to say forward. Let's say V1F. V1F, this is the final velocity, gentlemen. The final velocity of the proton is 2.25 times 10 to the negative 6. But if we're assuming that the initial velocity is positive, then we're going to say the final velocity is negative 2.2625 times 10 to the 6 meters per second. Now, if we assumed negative for the initial, then we would make the final positive 2.26. And that's okay. Okay, that's not a big deal. Now, this is where I thought it got a little bit tricky here. The alpha particle moves forward at 2.25 in the same direction as the proton was initially moving. So that's going to be V2. That's the velocity of the alpha particle, final V2F. And remember, we assumed that the proton was moving in the positive direction. So the alpha particle is moving in that same direction forward. We're going to make that positive 2.25 times 10 to the 6. Oh, this first one should have been 3.35, right? 3.35 times 10 to the 6. Christian, was that your hand there? 3.35 times 10 to the 6. It is negative because it's opposite to its initial motion, and the alpha particle is moving not in the same direction as it was originally moving, but in the same direction as the proton was originally moving, which we assumed to be positive. Now we're looking for the initial speed of the proton, v1I. Now, this question isn't insane once we get past the givens, but I don't know about you. I thought those signs were icky. I didn't like the way that this was worded at all. Again, it's a matter of sifting through those givens and sifting through those signs, and then it becomes basically like any other question. How about you guys? What did you think of the signs there? Was the wording of this kind of little mess you up on the signs a little bit? Yeah, I don't know. If you didn't find that, then that's very good for you. I found it a little bit challenging there. Okay, I'm going to say PI equals PF. We know what to do at this point, right? We've done this enough times. We would say, how many objects do we have? Well, how many objects do we have before this collision takes place? How many is there, Colton? 2. So we're going to say M1 V1I plus M2 V2I. Although the alpha particle is initially at rest, so we could have actually left that off if we wanted, because the initial velocity was 0. I'm going to put it in there because there is 2 objects. It's just that, well, there are 2 objects. It's just that the second object is at rest. So if you want to save yourself the bother of writing that down, you can. How many objects do we have afterwards? Nope, not one. We got two. We still have two, right? There's the alpha particle and the proton. They collide, but they don't stick together. So we're going to say M1 V1F plus M2 V2F. Now let's start subbing some numbers in here. I'm going to say 1.67. Ooh, I'm going to do something here, guys, just because I'm kind of a little short on space. My guess is that not a single one of you did this. I'm going to tell you that not a single one of you need to do this. I'm going to show you something that I can do, though, only because I'm short on space. I probably wouldn't have shown you this if I had a full page to work with here. Anybody see what it might be? Save myself a little bit of space here. Yep. I cannot cancel mass 1 because 1.67 doesn't appear in every term. It has to appear in every term on both sides. What does appear in every term on both sides? 10 to the minus 27. 1.67 times 10 to the minus 27 and 6.65 times 10 to the minus 27. So the masses are different, but the exponent is the same. So just because I've ran out of, I'm kind of short on space, I'm going to cancel the 10 to the 20, 10 to the minus 27. Does that make sense, you guys? I'm guessing nobody did that. That's fine. You don't need to. A little bit extra work in your calculator, but big deal. The only reason that I'm doing it, like I said, is just because I'm a little bit short on space here. So 1.67 times 10 to the minus 27 canceled out, times V1I, that's what I'm looking for, V1I, plus 0 equals M1, 1.67 times 10 to the minus 27, times V1F, which is negative 3.35 times 10 to the 6, plus M2, which is 2.25, no, it is 6.65 times 10 to the minus 27 times positive 2.25 times 10 to the 6. Do you see how that's legitimate to do that? We can cancel units that are in every term. So we could go kilometers per hour here, as long as it was kilometers per hour for all of the velocities. The units would cancel. 10 to the 6. Well, I'm not going to cancel the 10 to the 6 because it appears in both terms on the right side, but not on the left side here. Not in the, right? I don't see 10 to the 6 over here. But 10 to the minus 27, absolutely, that appears in every term. So I can, not that I need to, but I can cancel it out. All right, let's calculate this here now. Let's do the right-hand side first. Bracket 1.67 times negative 3.35 times 10 to the 6 plus 6.65 times 2.25 times 10 to the 6. Did I get the signs right in all those? Yeah. 9368000. And then I'm going to divide that by 1.67, and I get a, oops, 1.67, not 1.64. And I get 3.42 times 10 to the 6. Oh, yeah, you're right. You're right. I should use this and divide it by 1.67. Right. Thank you, Stein. 5.61 times 10 to the 6. And I mentioned a little while ago that there was a typo there that should have been 10 to the positive D. So my answer is 5.61 times 10 to the 6. A would be 5, B would be 6, C would be 1, and D would be 6. 5, 6, 1, 6. And I bubble that in like this. 5, 6, 1, 6. The B times 10 to the W, if I was asked to express this as B times 10 to the W, like we saw that the other day, I was not asked to express it that way. But if I was, I would have put B would have been the base 5.61. Now, B times 10 to the W, I have to include the decimal because they don't. But A decimal BC times 10 to the D, I don't need to include the decimal because they do. They do include it, I don't. They don't include it, I do. But like I said a couple times last week, if we ever have an issue, especially early on in Physics 30, you know, on a quiz or even your unit test next Monday, with how to express a numeric response, just ask me and I'll help you with how to express that. I want you to get the answer, but in terms of expressing it, I'll help you with that. At least in the short term, I will. All right, is that good? All right, let's take a look at number 2. A clerk working at a local food store is asked to retrieve the empty shopping carts left outside by shoppers. Each cart has a mass of 20 kilograms. The clerk places 8 carts close to the entrance on a slight incline. Meanwhile, the clerk gains another 12 carts, pushes them toward the store entrance. Meanwhile, the first 8 carts roll toward the 12 carts at a speed of 2.3, and then they collide, they come to a stop. So what's happening here? Let's picture this, okay? We've got 8 carts rolling towards 12 carts. They hit each other and they stop. That's it. Again, the wording of this one's a little icky too, but in the end, if you sift through it, it's not so bad. 8 carts right here, moving towards 12 carts right here, and they stop. Now, I'm going to say for this one, mass 1 is the 8 carts. 8 carts is 160 kilograms. I'm going to say mass 2 is the 12 carts. That's 240 kilograms. The 8 carts are moving with an initial speed, so that's going to be V1I of 2.3 meters per second. VF, they all come to a complete stop, 0 meters per second. And I'm going to say, what speed were the 12 carts moving? That's going to be V2 initial. Are those givens okay for you? Once again, if we get the givens written down here correctly, then we're probably okay. Nothing we had to deal with signs here. That made this one a little easier, I think, than question number 1. Question number 1, remember we had on that first page of our notes, the common mistakes problem. Watch out for the signs, the directions. We definitely could have been hit by that in question number 1. Some of us probably were hit by that in question number 1. Number 2, at least, everything we have here is positive. Although we would expect an answer here that is negative. If the 8 cars were moving positive 2.3 and the 12 cars were moving toward it, then their initial velocity for the 12 cars should be negative. All right, let's say PI equals PF. That's 2 objects before. That's the 8 cars and the 12 cars. Let's just make this, let's simplify this a little bit. What's the final momentum when the 8 hit the 12 and they stop? 0. Yeah, 0. They just, like, technically it's mass total times VF, right? But VF is 0, so I'm just going to put in 0 just to save myself the bother there. Okay, M1 is 160. As V1I is 2.3. M2, 240 times V2I. How many of you guys used 160 and 240? Yeah, that's good. Yeah. What if in this question we were not given the mass of each cart? What if in this question we were just told 8 carts rolled towards 12 carts and we didn't know what the mass was? You'd have a couple of options here. You can make up a mass as long as they were all the same. Or the other thing you could have did, I'm going to make this another color and then I'm going to erase it in a minute. You could have said 8m, whatever the mass of a cart is, times 2.3 plus 12m, whatever the mass of a cart is, times V2I. And then we could have canceled out m, the mass of each cart, an individual cart. It doesn't appear on the right side, but when it's a 0 on the right side, like, we can divide anything, 0 by anything, right? So even if we didn't know what the mass was, we could have 100% still dealt with that. I think that appears on your unit test. Maybe even your quiz, I can't remember. Might appear as early as your quiz tomorrow, but I'm almost positive on your unit test that you have an issue with that where you're not given masses. But like this, like they're all the same. So you can end up doing a canceling of the mass or make up a number for it, one of the two. All right, let's erase that. Go back to blue here. 160 times 2.3. Take that to the other side by subtracting. And then let's divide that by 240. I get negative 1.53. We expected a negative number, and that's what we got. They said positive 1.53, but they're only looking for a magnitude, right? The speed, not the velocity. How many more with it? Just number 3, or is there a 4 as well? Holy. Yeah, lots of work on that one, eh? 3. 2,100 kilogram van collides with a 1,200 kilogram car. It's at rest. They lock together. They move off at the speed of 4.5. What's the initial speed of the van? I'm going to say M1 is 2,100 kilograms. I'm going to say M2 is 1,200 kilograms. What do we got? What do we got here? Tell me something else that I have here. It's now officially 9 o'clock, so you've had a chance to kind of wake up and think. Now you can tell me one of the other givens here. Aiden, what's something else that I have given to me here? Okay, so they move off together, so we're just going to call it VF, not V1, V2F, just VF. Good, and that's going to be 4.5. 4.5 meters per second. Yep. Yeah. Good. Good. V2I, that's one of the ones where we got to read between the lines a little bit, right? Because it says at rest. You know, that means 0 meters per second. Good. And we're looking for V1I, the initial velocity of the van. You know, we could do impulse technically for this. We've talked about that before, right? But if we did, we wouldn't be analyzing the system of the car and the van. We'd be analyzing the car or the van. And unless we're looking for force, that's probably not the route we want to go down. We probably want to just stick with conservation of momentum. Unless you're looking for impact force, the force of impact between the two vehicles. Okay, how many objects do we have, Chad, before the collision takes place? Yep, 2 objects, 2 terms, M1 V1I plus M2 V2I. They lock together. So Dave, what's the how many objects are we going to have after the collision? If they walk together, just one. So we're going to call it mass total times VM. Good. 2,100 times V1I. That's what I'm looking for. Plus 1,200 times V2I. Oh, forgot V2I was 0. Some of you may have just made it 0 right off the top. Mass total is 3,300 times VF is 4.5. Gives me 70.7.
No.
What did I do? Oh, 210. Should have been 2,100. 7.07. Thank you. Now this one, to express that as 7.07, they don't give me the decimal. We're just looking for this in in standard notation. And since they don't give me the decimal place, I include the decimal place when I bubble it into my numeric response. But, like I've said a bunch of times, I'll help you with that as long as you have an answer for it on your quiz or your test. Lastly, number 4. A couple bumper cars hit each other. Look, you can see an east and a west here. Let's make east positive, west negative. This is one of those things that we identified in our common mistake sheet, right? Directions. Some of you, if you were to do this question on the test, would fail to take into account the negative for the west or get signs mixed up. You got to be careful of that, right? Let's write down some givens here. Izzy, what's something I got here? Just tell me something here from scratch here. Give me one of the easy ones. Okay, 1.25 times 10 to the 2. Laura, give me another one. 1.61 times 10 to the 2. There's another one where, because the 10 to the 2 appears in every mass, in every term, we could cancel that out if we wanted to. We don't have to, but if we wanted to, we could. Okay, good. What else we got there? Fatima, what's something else that I have given to me? V1I, the initial velocity of the lighter car, is 2.25, and we're making that positive, right, because it's to the east. Good. Ryan, what's another one? I don't got it. Good. V2I is negative 1.30 meters per second. Good. They don't stick together, right? So we're going to have two final velocities. Looks like V2F it's east, so it's positive 0.526, and we're looking for V1F. Good? Good, you guys? Okay, let's go through this, finish this one up. Aiden, how many objects do we have before the collision takes place? 2, good. So we're going to have 2 objects, 2 terms. M1 V1I plus M2 V2I. Kaylee, how many do we have after the collision takes place? Good. So we're going to go M1 V1F plus M2 V2F. You guys want to cancel the 10 to the 2? Make it a little bit easier, or do you want to just leave the 10 to the 2? Does that bother you a little bit by getting rid of those? How many people want to keep it? Okay, how many people want to get rid of it? So 1 person wants to keep it, 2 want to get rid of it, 3 want to get rid of it, and nobody else cares. I get it. Like, it's not a big deal one way or another, right? Okay, we will get rid of it since it was a 3-to-1 margin. The vote was a 3-to-1 margin in favor of getting rid of it. 1.25 times 10 to the 2 times 2.25. M2 is 1.61 times 10 to the 2 times V2I negative 1.3. M1 is 1.25 again times V1F plus 1.61 times 0.526. Our common mistakes, right? Watch this right there, right there. It's so easy. Even if we write down our givens, it's easy to just miss that when we're subbing it in. Now, what I'd like you to do, everybody hold out your calculators and do this with me, okay? We're going to calculate this side, and then we're going to calculate this, and then we know we have to solve for V1F in the end, right? But we're getting everything else first. So everybody do this on your calculator with me. I'm going to go for the left side, bracket 1.25 times 10 to the 2 times 2.25 plus bracket 1.61 times negative 1.3. Just going to press equals there. 0.7195 is the left side. You're going to calculate that other number there, 1.61 times 0.526 Gives me 0.84686. Now, I gotta get rid of what is not attached first. Solving for V1F. Get rid of what's not attached to the V1F. So what am I going to get rid of here? Tanzania, so what am I going to get rid of here? The 1.25 or the 0.846? Yep, and how am I going to take that over? Yep, good. So we're going to say, you're right, we're going to subtract 0.7195, subtract 0.846. There's the left side, and now let's just divide by 1.25. We get a value of a negative 0.102. And remember, I've told you guys sometimes that I don't really care how you express it, negative, or you could say to the west, whatever, as long as you know what the negative means. Okay? We know that it means to the west, so we would circle or bubble in A for our answer there.